Hey guys, it's Mrs. Coffee. I just have a few little reminders and a couple of notes to give you before you get to work on your assignment today, which I'm going to tell you about a little later. So first of all, we need to remember atomic mass. And we discussed the other day that atomic mass is very different from mass number because atomic mass is actually a weighted average. It is a weighted average mass of all known isotopes of that element. And when we discussed it, we actually used potassium as an example. And if you were to take a sample of all atoms of potassium, you would have isotope K39, isotope K40, and isotope K41. And so if we take a look at potassium up on the periodic table, we can see that the atomic mass, which is a decimal, which makes sense because it's an average, is actually closest to potassium 39. That's because in our example, potassium 39 is the most abundant. In other words, if you took a sample of all potassium atoms, you would come out with far more potassium 39s than potassium 40s or 41s. So that means that the average mass is weighted more towards that isotope because there's more of them. So, what that means for us is that if we want to make an atom of the most abundant isotope of a specific element, then I would look at its periodic table square, look at the atomic mass, and I can tell that the most abundant isotope of sulfur is going to be S32. If I look over here at boron, I check out its atomic mass. The most abundant isotope of boron has to be boron 11. So if you're ever asked to make an atom, build an atom of the most common isotope of an element, that's how you do it. Now a little bit of new information today, we're going to introduce the concept of the ion. And ions are atoms or molecules with an electric charge. So before today, we were dealing with all neutral atoms. In other words, the protons were always equal to the electrons. That made the atom neutral because protons are positive, electrons are negative, and so if we have equal amounts, those charges balance each other out to give you a zero or neutral atom. But now we have ions. And in ions, the protons do not equal the electrons. Instead, what happens is they start off as a neutral atom, but electrons are either lost or gained, and through that loss or gain, that atom is going to pick up an electric charge. If there are more protons, which have a positive charge, then that ion is going to be positively charged. But if the electrons are gained, that means we have more negative charges, so that ion is going to be negatively charged. So, the main idea with ions is that protons are not equal to electrons. The electrons are either lost or gained to cause an atom to have an electric charge. So, main idea here. Protons are never lost or gained to create an ion. It is only the electrons that are lost or gained. If we gain a proton, we become a different element altogether. For instance, if sodium gained a proton, it would become magnesium. no longer sodium, which means we're a total different atom. But ions are still the same element, but they have just gained an electric charge. So never lose or gain protons to create an ion. It's always loss or gain of electrons. Now, that is all of your notes for today. So what you're going to be doing is called Investigating Ions, and it's a worksheet up at the front of the room. So go ahead and go up there and grab it, and you're going to use a website that I have linked on Google Classroom. This is going to be due on Monday when we all get back. If you get done early, this same website has games available for you to play so that you can practice atoms and ions, and that's what you need to be doing until just a couple of minutes before the bell rings. Do not put up early. You should be busy the whole time. So that's the sub-report that I should hear on Monday. Email me if you have any questions. I'll get back to you as soon as I can. I'll see you guys on Monday. Have a great weekend.